So based on the area of the loop, they are classified into two: soft magnetic materials, hard magnetic materials. So they can be easily magnetized and demagnetized. This hard cannot be easily magnetized and demagnetized. They have high permeability, they have low permeability. And third point is low hysteresis loss due to small hysteresis loop area. See the loop area. Loop area is very less. Less is the loop area, less is the loss. Why? Due to magnetization and demagnetization, energy spent is also less. That's why the hysteresis loss is also less. Here the high hysteresis loss, we need a lot of energy to demagnetize, once again magnetize. That's why see the loop area is very high. Loop area is very high. That's why hysteresis loss, high hysteresis loss due to large hysteresis loop area. Next, see the coercivity and retentivity. Coercivity. What is the meaning of coercivity? The reverse magnetic field at which the magnetization of the material becomes zero is known as coercivity. Listen carefully. The coercivity means the reverse magnetic field at which the magnetization of the material becomes zero is known as coercivity. See, for soft magnetic materials, this value is very less. See, this is called retentivity. This is also less. So retentivity, coercivity and retentivity are small. See, for hard magnetic materials, this is very high and this is also very high. These values are very high. High values of retentivity and coercivity are hard. Eddy current loss is small due to high resistivity. Soft magnetic materials, eddy current loss is small due to high resistivity. Eddy current loss is high due to low resistivity. So one eddy current loss, or the second loss in the magnetic materials, one is energy loss. So this eddy current loss also gives some of its energy loss. So iron, so iron is a metallic element. It's a good conductor of electricity. When you place iron in the external magnetic field, what happens? An alternating magnetic field produces current in the circuit. So that is called EMF. When EMF is produced, it has its own magnetic field. That magnetic field opposes the applied magnetic field. Applied magnetic field. That's why it's called as eddy current loss. How this eddy current loss? You have to place this iron. Iron is a metal, is a good conductor of electricity, is a good conductor. If you place this iron in external alternating magnetic fields, when you place this iron in alternating magnetic fields, according to Lenz's law, an EMF is produced in this metal and it has its own magnetic field. Okay, that magnetic field opposes the applied magnetic field. That current we call as eddy current loss. So eddy current loss is small. The eddy current loss is reduced by increasing its resistivity. Generally, metals are good conductors of electricity. They have some mandatory property of resistance. I'm increasing that resistivity to high. How? By adding some silicon. 3 to 8% silica I have to add to iron. Pure iron cannot be useful. Pure iron, if you take, eddy current loss is large. To that pure iron, you have to add some 3 to 4% of silica. Then eddy current losses will be reduced. When you add silica, what happens? The resistivity increases. When the resistivity increases, conductivity decreases. Current means conductivity. So eddy current loss is small due to its resistivity. How resistivity is increased? By adding silica, 3 to 4% of silica to iron. The resistivity increases, the eddy current loss reduces. If you see hard magnetic materials, eddy current loss is high due to low resistivity. We cannot increase resistivity here in hard magnetic materials. The loss is there. Magnetic energy stored is small here. Energy stored, less is the area. Energy stored is also small. Energy stored is also large. No impurity or defects in soft sector. Next difference, no impurities and defects. So no impurities and defects. Soft magnetic materials. So why defects also impact on the magnetic properties of the material. If impurities are there, then the corrosivity value increases. So if impurities are present in the soft magnetic materials, impurities and defects are present in the soft magnetic materials, then corrosivity value increases. So there is no, in soft magnetic materials, there is no impurities and defects. If there are impurities, you have to avoid. If you consider hard, impurities and defects are more, quite opposite of this sort. Domain wall movement is relatively easier. Domain wall movement is difficult here. Next, next one. What are the, where you use this? Okay, electromagnets. Electromagnets we use soft iron. Soft iron. This is called. Iron is soft iron. So electromagnets, generators, transformer, cores, computer data storage. That's your memory. That's your memory card. Is a computer storage device. Okay, it's made of soft iron, soft ferrite. Computer data storage means memory cards in your computer. So there we use the soft magnetic materials. Electromagnets, generators, and transformer cores inside of transformer and generator. Transformer means voltage, current, frequency. Generators, we have AC and DC generators. In core of the generators, we use the soft magnetic materials. Computer data storage, that is called memory cards. Next, uses of permanent magnets. We heard about permanent magnets. DC. Permanent magnets, where you use permanent magnets. Loudspeakers also use permanent magnets. DC magnets. Okay. Permanent means it never loses its magnetism. That is called permanent magnets. They never lose their magnetism. They're called permanent magnets. DC magnets, loudspeakers. So all the video and audio, if you go to theater, there are a large number of big size of loudspeakers are there. In the loudspeakers, they use permanent magnets. They never lose their resistivity. It gives such a sound quality. The sound quality also depends on the magnetic material used inside the audio system. Magnetic tapes and disk, hard disk. So hard disk. So your computer having hard disk. The hard disk is made of permanent magnets. Even if you lose your OS or operating system, that your data is always stored in your hard disk. Disk tapes. Tapes means CD. CD. You have heard about CD, compact disk, which is rewritable. So read and write. Okay. So read means what is the energy stored in magnetic bytes. That is called magnetic tapes. CD. This is a hard disk. Loudspeakers, permanent DC magnets. We use these hard magnetic materials. So what are the materials we are using? So example is iron, silicon. So we don't use pure iron. We add with silicon. If we add silicon, then the resistivity increases, eddy current losses reduces. Alloy. What is the meaning of alloy? Mixture of metals is known as alloy. Mixture of metals. Iron, silica, nickel, cobalt. You have to take mixture and you have to prepare a best magnetic material. Iron, silica, alloy, ferrous nickel, alloy, soft ferrites. Soft ferrites are used. These are the examples. Next one is alnico, aluminum, nickel, cobalt, tungsten, steel, alloy, hard ferrites. So a magnetic storage device, RAM, use hard ferrites. For small storage devices, we use soft ferrites. Computer industries always use hard ferrites. They will have to store a lot of data. Hard ferrites. These are soft ferrites. Alnico is the best example for permanent magnet. Tungsten steel, chromium steel, these are the examples for hard and soft magnetic material. Just if you observe these differences, one is quite opposite. If you remember one, then it is quite opposite. Okay. So easily magnetized cannot be easily magnetized. High permeability, low permeability. Low hysteresis loss, high hysteresis loss. Corrosivity and retentivity are small, corrosivity and retentivity are large. Eddy current losses is small, eddy current losses is high. So we heard about eddy current testing also we can do in aeroplane. Aviation industry, they use the eddy current test also. There is called one of the tests called non-destructive testing. Eddy current testing in aviation industry. Magnetic energy stored is small, large. No impurities and defects. Impurity defects are more. Domain wall moment is easier, difficult. Electromagnets, permanent magnets. Simple way to remember soft and electromagnets, permanent. Electromagnets, soft iron. Permanent magnets, alnico. Alnico is the best material of making permanent magnets. Soft ferrites, hard ferrites. So this is about